Welcome back. Today I'm going to give you an overview of the B formal method, what it is used for as some industrial references, why it is used and some of its benefits, and how it is used to optimize traditional development cycle and the use of some specific related development tools. Atelier-B is a tool that directly supports the B formal method. It is mostly used for developing software using the B language and the B formal methods. Most of the time, the software is safety critical related because it's important for saving life for some kind of applications. But it is also used for modeling systems with the even B language. So if you are interested in more practical details, there is a YouTube channel for it. You will find the link in the additional material section. First, some words about the Atelier-B history and its three major releases. The version 3, used for different kinds of industrial applications like the first metro automatic pilot in Paris, line 14, EAL 5+ certification for the smart card industry, platform screen doors controller in Paris, line 3, and a symbolic calculus engine. During these 14 years, new features were added like automatic refinement, that is the ability to automatically generate part of the modeling, and the support for even B language. Version 4 supports modern platforms like Windows, Linux, and Mac, and all the new additions are released as open source software. Version 4 was also used in new kind of industrial applications like the safety assessment of your New York Metro Line 7, an XML compiler for large-scale simulator, a certified application running on low-cost microcontroller. The main added features were a generic C code generator that is not reserved for railways applications, a new way of relating model and proof elements in order to speed up the proof process. Finally, version 5 to be released end of 2017 with a new way of modeling to help the modeler to focus on its specification, and a code generator able to generate binary code. So, for the software development in B, the objective is to obtain a code that complies with its specification. 4 key ideas define the software development in B. The first one is modeling. In this case, the specifications come before the code. Specification program models are using the same mathematical formalism. Specification and program models are proved to be consistent. The program model is proved to comply with the specification, meaning there is no contradiction between the implementation and the specification. The code is generated from the program model, and the generating code hence is very close to the program model. The second idea is that we can't model any kind of software. B modeling is for modeling functions of single-threaded software. There is no interruption, able to modify software state variables. This is very important. And in case of multi-threaded software, we can use even B for modeling it. The third key idea is proving instead of testing. With B, errors are detected by proof while the software is being built and not by testing it once built. The proof is exhaustive, testing is not. A minima, software is proved to be programming error-free. The fourth key idea is the management of the complexity of the software. A software is made of several specifications and program models and not only one containing all the software. The program model may use other specification programs through function calls. The program model is said to be decomposed. The proof is layer, meaning that the program model is just using specification of other models and not the way they are implemented. And the proof remains always manageable as the complexity of the software is broken down at each decomposition. With even B for system modeling, the objective is to analyze and to verify system-level specification. Here, system is used in its widest meaning. It could be a procedure, can be a plan plus a controller plus its environment. It can be a parallel execution of software. Anything. A model contains the behavior of the system. So through a collection of asynchronous events that can be triggered based on some conditions and that can modify the system state variables, the behavior of the system is proved to comply with its properties. The modeling is progressive. The first model is simplified, meaning abstracted. We only have few state variables modeled. And then the model details are added to successive models, also called refinements. Events and properties have to be rewritten to consider these details. The refinements are proved to comply with their immediate abstraction, and by transitivity, most detailed models is proved to comply with top-level specification. So, considering B industrial references, we have selected two different kinds of applications. The first one is automatic train protection systems for the railways. This kind of system is supposed to avoid train collision by managing emergency braking. More than 30% of automatic metros worldwide are using this technology for onboard and trackside software. Another kind of application is platform screen doors controller, again for the railways. And the objective of this system is to avoid passengers to fall on the track when the metro is operated. Such systems are installed in metros like in Paris, São Paulo, Stockholm, or in diverse other locations. For even B industrial references, we have selected some different kind of applications, like the contribution to the safety demonstration for the railways, where we prove that the new signaling system enforces safety on the metro line in New York and in Paris. Or also the contribution to the security demonstration for smart card industry, where we prove that the security policy is enforced by the functional specification. Four basic concepts define the B formal method. First, B is a specification-oriented method. We have properties, static and dynamic descriptions. B is also based on mathematical language. We have predicates, sets, relations, functions, Boolean, integers, and so on. B is structured. We have the notion of module and refinement we will see later on. And B is also a framework for development validated by proof. The proof validations ensure a kind of systematic debugging. Structuring B. So B provides structuring mechanisms to help managing the software complexity, because the software is not contained in the single model. And it also is the related proof that is directly a function of the software complexity. And so the structuring mechanisms are modularity and refinement. Module is the first way of structuring B, to break down large software into smaller parts. A module has a specification and an implementation, and the module is seen only by its specification. Implementation contains implementable algorithm using standard control structures and possibly executing, meaning calling functions from other imported modules. For example, this function f1 can do something, then call f2, then do something else, then call f3. The B modules may call functions not developed in B, and be called from functions not developed with B. Variables are implemented and modified in one and only one module. Refinement is another structuring mechanism of B. Refining means adding implementation details. Can be either data refinement, in this case data type is made more concrete, or it can be algorithmic refinement, in this case processing is made more explicit. Or we can have both, data refinement and algorithmic refinement. The refinement is a relation between specification and implementation. With refinements, models are disposed vertically, the specification on top, the implementation on the bottom, that is so-called a refinement column. A refinement column may contain 0 refinement. The specification is implemented manually by so-called basic machine. 1 refinement. The specification is directly implemented by one implementation. Or 2 or more refinements. A B project can be seen as a tree with the specification and implementation connected by the import links. In this project, we have specification, implementation. Sometimes we have several refinements between specification and implementation. Sometimes we have specification but no implementation. The source code is in fact handwritten source code. For a B project, the proof ensures that every model is consistent and that any refinement complies with its specification. When put together, we are sure that at the end, the project is sound and complies with the specification. The only verification that is not performed by proof is a connection between specification and handwritten code that need to be go through regular testing. The code generation for a B project just consists in translating implementation into source code. For handwritten source code, there is nothing to do. The final software is just obtained by collecting all the source code generated plus the handwritten code. This is the final software. There are several benefits of using B for software development. For the abstract model, the requirements are formalized into B specification module by module and distributed. Non-formal and formal specifications are very close to minimize errors and are very easy to check. Software properties formalized in B must be proved that they remain true when the modules are put together. For the concrete model, we must prove that the concrete model complies with its specification. For the whole model, we can ensure that there is no classic programming errors in the code, no overflow, no division by zero, no out-of-range index, no infinite loop, and no aliases. We get a healthy program architecture, no unit testing, we can detect errors early in the process, and these benefits remain even after some modifications and evolutions. So there is also some benefits to use B for software development at the development cycle level. If we consider a traditional V development cycle with a number of different steps, we have some verification means, for example, at specification level, where we have validation testing, software specification, where we have integration testing, and design, where we have unit testing. With B, as we are able to cover all the specification software that is developed with B, we can ensure by proof that the software specification is correct. When we go to design, we can also prove that the design complies with its specification. And when we go for coding, we can also ensure by proof that the coding complies with its design. There is no more need for unit testing and no more need for most of the integration testing. We save time and we save energy. Let's make a quick comparison with other programming languages. For example, assembly language, where we have no static control. The C programming language, where we have very limited static controls. Or Ada, where we have extended static controls. For example, we have a strong typing. With the B method, we have the strong controls, but we also have a controlling over the program meaning, because we have to prove that the specification is consistent, but we also have to prove that the code complies with its specification. There are also some benefits of using even B for system modeling. At the B system level first, to deeply understand what the system is through the B model construction, it ensures a work in cooperation with system creators. It enables an early error detection at system design level, and it produces a better software specification. It's also a great help for remarks on the system, because most of the questions on the system arise during the B model creation, and a few inconsistencies may also be detected through model proof. And finally, it helps to produce interesting remarks on the system, and a natural language reformulation of the model, given a highly structured system description, is provided at the end. Finally, there are 4 tools that can be used with the B formal method. The first one is Atelier-B, that will be demonstrated during the next lectures. The second one is a Pro-B model checker, developed by the University of Düsseldorf, able to animate and verify B formal models. The third one is a B Motion Studio animator, able to provide a graphical representation to a B formal model. And the last one is a Roda platform supporting the Even-B language. You will find into the additional material section download links for these tools. This is all for today. See you soon for the next lecture.